in this problem, we've been given the null hypothesis that pi is equal to 0.4, the alternative hypothesis that pi is less than 0.4. The sample size is n equals 50. I do 100 repetitions in a simulator, and it tells me my sample statistic is p hat equals 15 out of 50, which is 0.3. And I give you a picture here of the actual simulation that I did with the Rossmann chance applet. And there's going to be a series of questions that we're going to answer in relation to all of this. Part A, what value would this distribution actually be centered at, and how do we even know that without that summary stats button being selected? Now notice, if it had been on proportion of successes, if that had been the button selected, we know that the distribution would be centered at pi equals 0.4, approximately, since it's a simulation. It won't be exactly 0.4 since it's a simulation, but it would be close. But it's actually selected number of successes right now. See, along the horizontal is number of successes rather than proportion of successes. So what it should be centered at is 40% of 50. The sample size is 50. So we expect our sample statistics to come out near 40% of 50. So 40% of 50 is 20. So it will be centered at 20. And when I say it should be centered at 20, since it's a simulation, it will be approximately 20, near a mean of 20 if you hit the summary stats button. Next, part B asks, if we switch to proportion of successes for the graph, what value would the distribution be centered at then? That's actually easier to answer. It would be centered at pi equals 0.4, or since it's a simulation, it would be approximately 0.4. Next, part C asks us to find the p-value. We can actually use this given distribution, this simulated null distribution, to find the p-value. Recall, if we assume the null hypothesis is true, then the p-value is the probability of getting a sample like ours or more extreme. So, in this situation, our alternative hypothesis is pi is less than 0.4. We need to count sample statistics, the dots in the distribution, that are like our sample statistic or less. Because the alternative hypothesis says pi is less than 0.4, we will count sample statistics that are like ours or less. So I go to my distribution. Notice there are 100 total dots here. I know that because it told me that it did 100 repetitions in the beginning of the problem. I can also see that there's a total of 100 here in the simulation screenshot. There's 100 total dots. So I first locate my observed sample statistic, which was 15 out of 50. So that's right here. I'm going to go ahead and just put a vertical line right at where our p-hat is, and I'll label that. My p-hat is 15 out of 50. There it is. And now I'm going to count the sample statistics that are like mine and lower. Okay, so right at p-hat equals 15 out of 50, there's 1, 2, 3, 4, 5 dots. I got to count those 5 dots and all the ones that are less than that as well. So there's 5 dots right at 15. Then there's additional 4 here. So there's 5 right here, 4 more here, 2 more here, 3 more here, and 1 there. That's 15 total dots out of a total of 100 total dots in the null distribution. Okay, so part C again says we need to count the sample statistics, the dots that are like our sample statistic or less. That's what a p-value is. If you assume the null hypothesis is true, then this is the distribution we would get, the distribution of sample statistics. And so our p-value is 15 out of 100, which is 0.15. Our p-value, the probability of getting a sample like ours or less if the null hypothesis were true.